Thank you, Jillian. And good morning, everyone. Welcome again. We have a panel for you this morning, but we're going to start off with a presentation from Santiago Carrizosa. And then from that presentation, we'll move right into a panel and I'll introduce the panelists at that moment. But for now, Santiago, we have a presentation on investing in genetic resources under the Nagoya Protocol, the potential of private sector industries to generate social, environmental, and economic benefits. And the presentation will lead into the panel. It's all about private sector investing. We heard a lot yesterday about how we can try to increase the amount of financing, better align private sector actions so that they're less damaging to biodiversity and more beneficial to biodiversity. And so today we'll hear a range of ideas, and you'll have a chance also to ask questions at the end of the panel about how we can get this done. And we'll start off with Santiago. Thank
you. Thank you, David. I will give a very brief presentation that has two key objectives. The first one is to provide an overview of the potential of the private sector industry to generate social, economic, and environmental benefits from the development of products that use genetic resources. And the second objective, is to underscore the fact that these industries, these private sector industries, can access these genetic resources only if they comply with the rules and regulations of national access and benefit sharing laws or policies. So with this in mind, it's not working? There you go. So with this in mind, let's look at the agenda for today. I will highlight some of the basic principles of ABS. Then I will describe what is the global market size of products derived from genetic resources, which are the key characteristics of the main industries that use genetic resources. And I will focus on research and development issues in this case, and also on the product development process, and I will conclude with some thoughts regarding the presentation and the issues. So what is ABS? And by now, you should have realized that ABS is not related to the anti-lock braking system of the car industry. Rather, ABS stands for access to genetic resources and benefit sharing. And specifically, the Nagoya Protocol describes ABS as the fair and equitable sharing of the benefits arising out of the utilization of genetic resources on the basis of prior informed consent and mutually agreed terms. But why a protocol on ABS? Why do we need that? And the answer is very simple. We just need legal certainty and transparency. And we need this for providers to ensure benefit sharing once resources left the provider country, and to prevent the misappropriation of genetic resources and associated traditional knowledge. And we also need this, for users to provide for clear and transparent procedures for access to genetic resources. We should also remember that the scope of the Nagoya Protocol includes genetic resources associated to traditional knowledge, and this is a very important point. Now, the Nagoya Protocol also contributes to clarify the difference between biotrade and ABS. Biotrade is basically the production and trade of, for example, green commodities, coffee, cocoa, non-timber forest products. On the other hand, ABS relates to the utilization of genetic resources, which is to conduct research and development on the genetic and or biochemical composition of genetic resources. And it's very important to have this clarity as companies approach governments that wish to access genetic resources. Of course, users and providers of genetic resources can negotiate benefit sharing agreements, and in the context of these agreements, you can negotiate monetary and non-monetary benefits that include access fees, milestone payments, license fees, royalties, transfer of technology, sharing results of research and effective participation in research, and of course, education, capacity, so on and so forth. So genetic resources can be used for or inspire the development of a wide range of products of the pharmaceutical, cosmetics, botanicals, biotechnology, seeds, crop protection, food, and beverages. And you can see that the global market ranges between 955 million of the pharmaceutical industry, all the way down to 23 billion of the food and beverages industry, and this is a segment that relates to functional beverages, and I will talk about this later. I would like to refer now to some characteristics related to the research and development phase of three key industries. These are the pharmaceutical, biotechnology, and the food and beverages industry. In the case of the pharmaceutical industry, we have found that most of the programs that collect samples from nature are based in small and medium-sized enterprises, government programs, and universities. Today, we don't have the case of these huge pharmaceutical industries, with programs that collect samples from nature. They have closed. Now they are relying on these small-sized enterprises. Also, there's a high degree of science and technology, especially genomics, that allows for faster and deeper screening, especially on microorganisms, and the possibility to grow them and overcome supply. 20 years ago, the screening of 1,000 samples took maybe a year or so. Today, this can be done in just a matter of days. So this is a significant development. And also, it's important to note that there's a decreasing interest in traditional knowledge due to focus on microorganisms. With respect to biotechnology, today we're beginning to see a focus on enzymes and metabolites from microorganisms that can endure manufacturing conditions such as pressure and heat. There's also a high degree of science and technology, and this is less costly and risky than research and development in the context of the pharmaceutical industry. Also, some companies do bioprospecting in extreme environments, for example, in hot springs, but most use existing collections or domestic genetic resources that they basically found in their backyards. In the case of the food and beverages industry, we have that there's relatively low level of research and development, but some subsectors are starting to rely on innovation. There's also a focus on health benefits, weight control, and energy supplements. Now, this slide illustrates the product development process in the food and beverages industry. And I put it here just to make the point that national access and benefit sharing policies or laws need to adapt to the business models of these industries. For example, in this case, we have three phases. The pre-product concept that can last between 6 months and 10 years with an investment of 1.14 million. The research and development phase that can last between 1 to 5 years, and there's also an investment of over 1.14 million. And of course, the business plans for production, sales, and marketing phase that comes once the research and development phase has concluded. So the question is, how can national access and benefit sharing laws or policies adapt, to this reality, to this business model? Well, by being flexible and negotiating, for example, prior informed consent and negotiating benefit sharing agreements at different stages, during this development process. For example, at the beginning of the research and development phase, when there is less certainty and high risk, there's less certainty that the product will be developed, so they cannot negotiate the world, with the government. Also, at the end of the research and development phase, when now there's more knowledge, about the product that was developed, and of course, during the sales and marketing phase, when the company has a pretty close idea of the amount of benefits that will be generated from the product and can negotiate monetary benefits, with the government or the providers of the genetic resource. Some conclusions. As we just saw, research and development and product development processes are complex and differ even on a case-by-case basis. It's very important to keep this in mind. And this is why it's so important to train government negotiators on the different business models of industries, of all the industries that I just described in the presentation. There are also common elements, to these industries, some of these industries, 4 sectors at least. There are go and no-go decisions throughout the research and development process because of the uncertainty, that the research and development implies. There are also intellectual property considerations that need to be taken into account, royalties, license payments, copyrights. These are issues that are complex and that need to be part of the knowledge that is generated, at the level of government officials involved in this kind of negotiations. There's also the development of science and technology is changing industry practices with the use of genomics. And there are also huge variations between these industries and sectors. The level of science and technology used regarding the need to access genetic resources. The need to access genetic resources can be continuous if we talk about plants, for example, but it can be limited to a collection of a tiny sample. And this is if we collect, for example, microorganisms that can be grown in the laboratory during the research and development process. There's also the level of internal research and development that can be ranges from 100% in-house to outsourcing of research and development to to small and medium-sized enterprises. And of course, the ABS national laws and policies need to reflect the realities of business models, as we saw in the slide on the food and beverages industry. The authorization process must be flexible, and it's important to adapt timing for the prior informed consent or for the negotiation of access and beneficiary agreements. Outreach and information on ABS is also essential for building trust between users and providers of genetic resources. And one key point that many governments just don't take into account is that national science and technology policies must include incentives for the development of bioprospecting projects implemented by local research and private sector organizations, so that countries that are rich in biodiversity, countries that are rich in genetic resources become users of these resources and not only providers. Thank you very much.